We're heading deep underground. And 250 million years into the past. Here in Britain's deepest mine, the hunt is on for the world's most puzzling particle.
We think there's missing matter out there.
So where is it? Why can't we see it? What kind of stuff could be there that we couldn't see?
Tucked away in the northeast of England is Bowlby, a working polyhalite and salt mine, the second deepest mine in Europe. In a small corner of the mine is a unique laboratory that could hold the answer to one of the biggest mysteries of the universe. It takes a 7-minute lift ride to descend through 1,000 metres of rock. After that, you're faced with a 15-minute walk through a labyrinth of hot, dusty tunnels to reach the lab. Over 1,000 kilometres of tunnels have been excavated here. This enormous subterranean network extends 7 kilometres out under the North Sea through a layer of 250 million-year-old rock salt, the remnants of an ancient sea. After hosing off the prehistoric dust clinging to our boots, we finally reach the lab, where scientists have spent the last 2 decades searching for dark matter.
We think dark matter makes up 85% of all the stuff in the universe. So subatomic particles are an as yet unfound kind that is everywhere in space, all around us now, that is just very subtle and difficult to detect. And so how we prove it exists is to build and run experiments like this.
This is Sean Paling. He leads the team of scientists and engineers here at the Bowlby Underground Laboratory.
So the theory is that dark matter particles are everywhere. They're streaming through us now and our detectors now. And once in a blue moon, one of them will hit an atom of our detector. That atom will get a bit of energy and we'll detect that atom. We won't actually see the particle. The particle will hit the atom of the detector and that dark matter particle will continue through the Earth. It's like looking at a snooker game, if you like, where the white ball, for instance, is a dark matter particle. We don't get to see that. We get to see the red ball when it shoots off and has been hit by the white ball. This is called the direct search for dark matter. That's the proof that everyone's looking for now.
And there's a very good reason why this lab is so far underground.
We have particle physicists who want to do very difficult, subtle experiments that need to be away from interference. And when you're on the surface of the Earth, you're being bathed in natural radiation. And so here where we are now, we've got a kilometre of rock above our heads, and it shields us from that interference by about a factor of 1,000,000.
So in theory, that machine or that machine there could go ping now, and you could discover it.
I wish it was as simple as just that will go ping any minute now. Even though we're a kilometre underground and it's a very quiet environment because a lot of radiation is absorbed from the surface, the materials of our detector are slightly radioactive. You know, we as humans are slightly radioactive. So the machine actually goes ping, ping, ping quite a lot, but often it's pings due to background radiation, not dark matter particles. So we have to make these machines to be very clever, so they make a different ping for dark matter particles than to the other pings from background radiation.
What would it mean for science? What would it mean for humans? What would it mean for regular people if you were able to prove dark matter does exist?
It would answer a huge question in science of what is the universe made of. So it would give us a big boost in knowledge. You know, what good is that to humankind? Well, there's 2 types of science really. There's fundamental pure science and there's applied science. Applied science is when you know you've got a problem you're trying to solve, making a mobile phone smaller, making cars more efficient and more environmentally sensitive and things like that. Fundamental science is just answering the obvious questions that are in front of us. But the value of that is not just knowledge for knowledge's sake, is it builds up our understanding of how things work, and that understanding then becomes applied science. So why we do it is to answer obvious questions in front of us, but it has a later use of building up our knowledge so we can do things better as humans.
Scientists have spent decades searching for dark matter, and yet no one knows when it'll be found or if it even exists. So how confident are the team of making a breakthrough?
We don't know when we're going to hit it, but we know approximately how long we need to look to explore all the ones we think it might be. You know, it could be in the next year we find it, or our colleagues around the world, or it could take up to, it should be less than 15 years. We should have done everything we can to explore all the candidates by that, something like 15 years, but it could be next year. You just don't know.
I won't lie, I would be a little bit disappointed if we got to the end of that search and realised that dark matter in the way that we think it might be didn't exist. It would be a little bit disappointing. We've put a lot of work into that and it makes sense. It is the more sensible answer. But if it's not, it's also really exciting, because then what else is it? Then we have to go all the way back to the very beginning of this and say, right, what else could it possibly be if it's not this? Which is still a really exciting question.
This mine isn't just proving useful for the search for dark matter. These walls are 250 million years old. This used to be a seabed, and the life contained in the salt in these walls could be crucial to the search for life on other planets. Why is someone from NASA here at the Bolby mine in North Yorkshire?
So we are at Bolby this week to understand how life thrives in the deep subsurface. There are features that are able to be preserved within the surface minerals of Mars, and the probability that there would be life and also habitable environments, that will increase as you go deeper into the subsurface.
So this acts as a kind of a substitute, a proxy for Mars.
Yes. So we're actually developing a Mars deep drill concept that actually would go down to about 100 meters on Mars. And so having the actual Bolby mine as a test bed for that kind of drill facility and that entire setup would allow us to replicate what a Martian mission would be just here in the mine.
And this is working on the basis that on planets like Mars, there was once water present there, which has dried up and has left a similar condition to this.
Exactly. So it's not just Mars in terms of ancient water, but it's also Europa as well as Enceladus, where you have fluid water present right now.
And you've got that really interesting juxtaposition there, haven't you, where clues for what is happening in the vastness of space can be found a kilometre under a small village in North Yorkshire.
That's fair, yeah. Yeah, it's something that actually shows both modes of preservation. These are the same kind of minerals that we'd find on Mars as well as Enceladus.
Right, we all good? Let's go.
Meanwhile, the global race to discover dark matter shows no signs of slowing. And while the particle continues to prove frustratingly elusive, hope remains that its discovery will help answer some of life's biggest questions.